All right, here's our free fall test review for our test that is coming up on Friday, November 2nd. Number one, it says when you drop an object, it accelerates downward because of gravity. We know that the force that pulls things down in a downward direction is due to gravity, and the rate at which things fall down or slow down as they go up is 9.8 meters per second squared in a downward direction. So we represent it as a negative 9.8. So right now, if I were to drop feathers and rocks at the same time, I know that the rocks would hit the ground first, not because they are being pulled harder by gravity, but because there's an increase in air resistance that is pushing up against the feathers, causing them to fall down at a slower rate than the rocks. So if that gravitational attraction, if the rate on Mars is lower than it is here on Earth, then that means that objects on Mars would fall at a slower rate than they would here on Earth. So less of an acceleration of gravity means that things fall slower. A higher rate of acceleration means that they're going to fall faster. If I look down here at number 5, it's asking me to draw the distance time graph, and number 6 says the velocity time graph, and I've already set those up for you. And it's referring to objects that rise and fall. So just to kind of give you a diagram of what that looks like, if this is my object and it gets thrown up into the air and it's going to come back down. Okay, well, as it moves upwards, it starts to slow down until it reaches its highest point, where it changes direction and comes back down in an increasing speed in a negative direction. So what does that look like on a distance time graph? Well, if my ball is moving away from me because I threw it up, it's moving away, that's a positive slope, and it's slowing down. It's not constant, so I shouldn't have a straight line. I'm going to show a line that is starting off fast and ending slow. So on my distance time graph, I will have part of the graph start off steep and end flat, showing that it's moving away and slowing down. However, the ball doesn't just stay up here suspended in air, it changes direction and comes back down. So now it's moving towards the reference point, so it's going to have a negative slope, and it's speeding up. So it's going to start off flat, and I'm going to pick up where I left off and get steep. So this line is really a continuous line. And let's see if I could draw it a little bit better. It's going to look like this. It's going to be a nice little curve. Okay, and what does that look like in terms of acceleration? So in my velocity time graph, I need to represent the same thing. So what I'm seeing here is a positive slope. So if I did this, let me show you. If I took this pathway and I kind of separated it, you'll notice that the left side mirrors the right side. They're mirror images of each other. The only thing that's different here is that this velocity is slowing down, and on this side it is speeding up. The direction is away, and the direction is towards. Other than that, they are mirror images of each other. So let's break this down. If I have something moving away that's got a positive slope, and if I transected that, it would be right here also. First part of my graph shows a positive slope, so that means positive velocity down here in quadrant 1. Second half shows a negative slope, which is going to be down here in quadrant 4. So positive slope, quadrant 1, and it's slowing down, which means my line needs to approach 0. And then after 0, when it reaches its highest point, now it has a negative direction and it's speeding up. So my line is going to continue moving through the x-axis and getting away from 0. So the first part shows the line is approaching 0, it's slowing down, and then it changes direction and it moves away from 0, showing that it's speeding up as it comes back down. Okay, so let's look down here at number 7. We saw an example or a video where a bowling ball and feathers were dropped simultaneously in a vacuum. Now, before the air was removed from that chamber, the bowling ball hit the ground first, similar to the situation up above, because the feathers were experiencing air resistance. Well, if I remove all that air, and that is not a factor, then the only thing that is affecting those objects is gravity. And gravity pulls all things down at the same rate. It's unbiased. It pulls big things, small things, all down at the same rate. So if the bowling ball and the paper were dropped at the same time in free fall, this is your key right here, free fall, then both will land at the same exact time. Okay, so just to recap here, free fall is describing objects that fall under the sole influence of gravity. There is no air resistance. Yes, we know that if I drop two things in my classroom, then there is air. However, we're going to pretend when we're discussing free fall that air does not exist. It does not play a part in objects that are falling. Okay, for numbers 9 and 10, I've got a diagram down here to kind of represent a ball that's being tossed up into the air, similar to our problem up above, and then it's going to come back down. Well, I need to know a couple things that are very important here. I need to know the velocity at the highest point and the acceleration at the highest point. These two things never change. So, as I approach the top of the path here, my ball slows down. And at this highest point, it's no longer going up. It's yet to come back down. It's just changing direction. Okay? Now it's changed its direction. Now it starts to come back down in an increasing velocity. But at that point, at this highest point right here, if the ball is no longer going up, it's yet to come back down, it's basically stationary. So the velocity at the top of its path will be 0. And this also is true for things that are dropped. At the highest point, at the top of its path, its velocity will be 0. Now, what about acceleration? Well, gravity doesn't go away. Just because you stop moving, gravity doesn't stop pulling on you. It's pulling at you the entire way up and the entire way down. So gravity is one thing that you cannot escape. It is negative 9.8 the entire way up and negative 9.8 the entire way down. So the acceleration of the ball, even though it's not moving at its highest point, is still negative 9.8 meters per second squared. If I can get this, there we go. Meters per second squared. Okay, this is a constant. The acceleration of gravity is a constant. It does not change. It is negative 9.8 no matter where you are along this pathway. You could be at the bottom being held in the hand. You could be halfway up, at the top, halfway down, or at the bottom again. The velocity, the acceleration of that object will always be negative 9.8. This is a constant. It does not change. Okay, on the right side here, we've got some information that's up at the top of our page that we're going to use for questions 11 and 12. And it says that little Jimmy accompanies his family to the second floor of his treehouse, so they go to enjoy the view of his skyline. While they're there, Jimmy drops a penny off the deck, and it tells you the observation deck on the second floor is 3.73 meters above the ground. And we need to ultimately figure out how long it's going to take and how fast the penny is going to go. Okay? So the only information that it gives us directly is how high the second floor is. So what it's telling us is the distance above the ground is 3.73 meters. And there's some other information that we need to, that's kind of implied that we need to think about, and it's the fact that it's being dropped. So this penny is being dropped, which tells me two things. One, anything that's being dropped starts off at rest, so its initial velocity is 0. And if it's dropped, that means that something is pulling it down, and that something is the acceleration of gravity, which is negative 9.8 meters per second squared. Okay, so we ultimately want to figure out how long it's going to take the penny to hit the sidewalk. So how long is referring to time. So time is unknown. I'm given, or I know the distance is 3.73, the initial velocity is 0, and the acceleration of gravity is negative 9.8. So I need an equation that's got VI, A, D, and T. I can't use any equation that has VF because I don't know how fast it's going at the bottom of its pathway yet. So the equation that includes VI, A, D, and T is D equals VI T plus 1/2 AT squared. Okay? So I've identified my equation. Now all I have to do is substitute. So for D, I'm going to write 3.73 equals my initial velocity is 0. My time is unknown. So I'm going to write it as a T plus 1/2. The acceleration of gravity is negative 9.8 times T again squared, which is unknown. So when I look at this problem, I see something that stands out to me, and it's the fact that 0 is being multiplied by T. Well, even though I don't know what T is, I know that if I multiply it by 0, I get 0. So this part goes away. So what I'm left with is 3.73 equals, and I have 1/2 times the negative 9.8. So in other words, 0.5 times negative 9.8, or half of negative 9.8, is a negative 4.9 T squared. So I've got a negative 4.9 times T. Now you might see this and think, well, this is a minus 4.9, so I need to add 4.9. Yes, it's a negative, but the operation between 4.9 and T is multiply. So the opposite of multiply is to divide. So when I divide both sides by a negative 4.9, then these 4.9s cancel. And I'm left with 3.73 divided by 4.9. And 3.73 divided by 4.9 gives me a negative 0.761 equals T squared. Now, you should know that you can't take the square root of a negative. Furthermore, you can't have a negative time. Time is a scalar value. It cannot be negative. It does not tell me direction. So either way, I need to get rid of this negative. So you can simply just erase the negative, or when you type it into your calculator, just leave the negative off. That's fine. I need to get T by itself, but it's being squared. So the opposite of squaring T is to take the square root of T. And when I do that, I take the square root of a negative 0.761, I get 0.87 seconds as my answer. And number 12 says, ignoring air resistance, how fast is the penny going when it hits the sidewalk? So I ultimately want to know the final velocity. And everything else that I knew up above is still true. I still know that the acceleration of gravity is negative 9.8. I know that the initial velocity is 0. I know that the distance that the penny is 3.73 meters, and I'm solving for VF. Now, we could use our time that we just calculated to figure out how fast it's going, but like I presented in class, if you aren't sure if your answer is correct or if it is incorrect, and you plug an incorrect time into your equation, then you're also going to get another incorrect answer. So with the information that I know for sure, I can still determine the correct answer. So A, VI, VF, D is the equation. A equals VF squared minus VI squared divided by 2 times D. So when I start plugging that in, or plugging in my values for A, I know A is a negative 9.8 equals VF is unknown. I'm going to leave it. VI is 0 divided by 2 times my distance is 3.78. So I look at this problem, and right off the bat I can see that 0 squared is 0. So this part goes away. So I have VF squared divided by 2 times 3.78. Well, if I want to simplify even further, 3.78 times 2 gives me 7.56. So I'm going to erase this bottom part for the sake of space and rewrite it with the simplified format. So I end up with, I didn't mean to erase that, I end up with VF squared divided by 7.56. Okay, so I've got a fraction on the right. I can make a fraction on the left by putting it over 1 and cross multiplying. So when I do that, 7.56 times a negative 9.8 gives me a negative 73.108, and then 1 times VF squared gives me VF squared. So I need to get VF by itself. So in order to get rid of the exponent, I need to take the square root. Now again, you can't take a negative square root, but the negative just tells me direction. So it tells me that the object is moving downwards a certain velocity. So I'm going to take the square root of a positive 73.108 and add the negative at the very end. So the square root of a negative 73.18 or a positive 73.108 gives me 8.55 meters per second. Now I can't forget that it's moving in a downward direction, so I got to put the negative back on there, and negative 8.55 meters per second is my answer. Okay, let's look up at the next question. This information I'm going to use for, it says 12 through 16, it should be 13 through 16. Okay. It says Jose throws a rock straight up with an initial velocity of 34.5. So just to kind of show you what the rock's doing is it's going up and then coming back down. Okay? It says that it's thrown upwards with an initial velocity of 34.5 meters per second. Okay? And it doesn't tell me anything else, but I know that acceleration, gravity, is slowing it down on the way up and then speeding it up on the way down. So I also know that gravity plays a part. So I also know A. Okay, So I want to know how high the rock is going to go. So I'm really looking for D. So D is unknown. So I got VI is 34.5, A is negative 9.8. I want to solve for D. I also know, what we mentioned on the previous side, is that at the highest point, the velocity at the top is 0. So if I'm starting down here and I want to know the height, which is at this position, my initial velocity is down here. This velocity that I know is 0 is my final velocity. Okay? So final velocity is 0. We've identified acceleration, initial velocity, and we're solving for distance. So VI, VF, A, and D gives me the equation A equals VF squared minus VI squared divided by 2 times D. So when I plug in my information that I know, A is negative 9.8 equals VF is 0 squared minus the initial velocity we said was 34.5 squared divided by 2 times D, which I don't know yet. Okay? So looking at my numerator, I see 0 squared. 0 times 0 is 0. So I can get rid of that part right here. And I'm just left with the negative 34.5 squared divided by 2D. Okay? So I can cross multiply. And I'm going to take the 2D and multiply by negative 9.8. And remember, this is over 1. So take 1 and cross multiply by negative 34.5 squared. And when I do that, it simplifies to negative 9.8 times 2D is negative 19.6D equals, and 1 times the negative 34.5 squared gives me a negative 1,190.25. And my last step is to get D by itself. So I'm going to divide both sides by negative 19.6. And I get D all by itself. And a negative 1,190.25 divided by a negative 19.6 gives me a height or vertical distance of 60.73 meters. Okay, number 14, how long will it take the rock to hit the ground? So now I want to know time. So how long will it take the rock to hit the ground? So in other words, it's asking me how long is it going to take for the rock to go all the way up and all the way down. Well, if I know information at this point, halfway through its path, if I can figure out how long it takes for the rock to go from here to the top of its path, all I need to do is multiply the time by 2 to get the total time. Because remember, each side of this pathway is a mirror image. They are equivalent. The only thing that's different is the direction. Okay? So, if I know the acceleration is a negative 9.8, I know the initial velocity is 34.5. I know the final velocity is 0. And I want to find time. So A, VI, VF, and T. Yes, I can solve it if I use D in my equation. But remember, if D is incorrect, then time will also be incorrect. So I can solve it without using d, using a equals vf minus vi divided by t, where a is a negative 9.8, vf is 0, initial velocity is 34.5, and time is unknown. So 0 minus 34.5 is a negative 34.5, so I'm going to get rid of the 0 part, and I can cross multiply. Set it up over 1, cross negative 9.8 times t, and 1 times a negative 34.5. So a negative 9.8 times t gives you negative 9.8 t, and 1 times a negative 34.5 gives you negative 34.5. So to get t by itself, I need to remove the negative 9.8 by dividing both sides, where these cancel, and I have t all by itself. And a negative 34.5 divided by a negative 9.8 gives me 3.52 seconds. However, that is the time that it takes to go to the top of its path. So that's the time it takes to go from here to the top. I want to know the total time. So the time it takes to go from the bottom to the top is the same amount of time as it takes to go from the top back to the bottom. So all I need to do is take 3.52 seconds, multiply it by 2 to come back down, and I get 7.04 seconds total. That's my total time up and down. Okay, and number 15 says, how fast will the rock be going 2 seconds after it's thrown? So how fast is velocity. Seconds measures time. If it's already thrown, it told me the initial velocity, so that means I need to solve for final velocity after 2 seconds. Okay, so let's recap what we know. We know acceleration is negative 9.8. I know the initial velocity is 34.5. Okay, it's telling me after 2 seconds, so the time that it's giving me is 2 seconds. And I want to solve for final velocity. So VI, VF, A, and T gives me the equation A equals VF minus VI divided by T. And now I substitute. So A is a negative 9.8. VF is what we're trying to solve for. T is 2 seconds. Oops, excuse me. VI is 34.5. Now T is 2 seconds. Okay, so VF is in the numerator. It's part of a fraction. I'm going to make a fraction on the left and cross multiply. So that I get a negative 9.8 times 2 gives me a negative 19.6 equals, and 1 times VF minus 35, or 34.5 is just VF minus 34.5. So VF has a minus 34.5 out there. The opposite of subtract 34.5 is to add 34.5 to both sides. When I do that, these cancel, and a negative 19.6 plus a positive 34.5 gives me a positive 14.9 meters per second. Is how fast it's going after 2 seconds. You'll notice that it started off at 34.5, and as it goes up, it slows down. Okay, so we know that it's approaching 0. So as it goes up, 2 seconds later, let's say it's right here, now it's 14.9 meters per second. And as it keeps going up, it's going to reach 0 and then speed up on the way back down. Okay, so let's look at the last one on this page. Number 16. This is how fast will the rock be going when it hits the ground? So now I want to look at the final velocity as it comes down. Now, this one doesn't even need a calculation, and here's why. If my rock is going up and coming back down, we've already said that this pathway is symmetrical in that the left side going up is equal to the right side coming down. So if I have at this point a positive 34.5 meters per second, then if I find the same position on the other side of the pathway, if they are truly mirror images of each other, then this point, the opposite point on the pathway, is the same velocity but in a negative direction, because now it's moving down. So this should be a negative 34.5 meters per second. I don't even have to do the math because I know that both sides of my pathway are symmetrical. So the rock will be traveling 34.5 meters per second in a downward direction on the way back. All right, on the back. All right, number 17. If you were an explorer on Mars and found a hammer dropped from a height of 9 meters and took 2.72 seconds to hit the ground, calculate the acceleration due to gravity on Mars. Okay, so let's look at what we got here. It's telling me that, first of all, I'm on Mars. Okay, so I'm not on Earth, so things are a little bit different. A hammer is being dropped from a height of 9 meters, so that tells me the distance. It's telling me that it took 2.72 seconds to hit the ground, so that is time. I need to calculate the acceleration due to gravity, so I'm solving for A on Mars. Okay, so acceleration of gravity on Earth is negative 9.8. I can't assume that it's going to be the same acceleration on every other planet because every planet has a different mass. So I've got distance is given to me directly, time is given to me directly, acceleration I need to solve for. What's not given to me is the initial velocity. So remember, anytime something is dropped, its initial velocity is 0. Okay, so I've got VI, A, D, and T. My equation is D equals VI T plus 1/2 AT squared. Okay, so for D, I'm going to plug in 9 meters. Initial velocity is 0. Time is 2.72 seconds plus 1/2. A is unknown. Time 2.72 again squared. Okay, so right off the bat, anything multiplied by 0 is going to cancel out, so that goes away. And I'm left with 9 equals 1/2 A 2.72 squared. So what I like to do is I like to do everything on the right side, starting with the exponent. So 2.72 squared times 1/2, or times 0.5, gives me 3.692. 3.692. And I still have A, can't forget A, and it all still is equal to 9, that doesn't change. And I can see here that 3.692 and a are being multiplied. So to get a by itself, I have to divide both sides by 3.692 and 3.692 on this side. These cancel, and I've got a all by myself, or by itself. And I simply just need to do 9 divided by 3.692, and I get 2.43 meters per second squared is the acceleration of gravity on Mars. All right, next one. Number 18, a stone is dropped into a deep well. It hits the water 3.41 seconds after being dropped. How deep is the well? Okay, so a couple things. It tells me that it hits the water in 3.41 seconds. That is time. It is being dropped, so that should tell you that gravity is pulling it down. And the initial velocity is 0. Okay, how deep is the well? So you're asked to solve for distance. So I've got time, acceleration, initial velocity, and distance. So I'm going to use the same equation that I used above. D equals VIT plus 1/2 AT squared, where D is unknown. The initial velocity is 0. Time is 3.41 seconds plus 1/2. Acceleration is -9.8 times 3.41 seconds again, squared. Okay, so anything multiplied by 0 is 0, so that goes away. And it just comes down to, can you type this into the calculator? So 1/2 times -9.8 times 3.41 squared. I like to work with the exponent first. 3.41 squared times a -9.8 times a half should give me a distance of a -56.98 meters. So why is it negative? Well, if it's falling into a well, it's falling downwards. Its direction or displacement is in a downward negative direction compared to where it started. Okay, let's move down. Number 19. It says a ball is thrown into the air by a boy. It travels 38.4 meters into the air to reach the top of its path. What is the initial velocity of the ball? Okay, so I'm going to draw the path of the ball to help you kind of visualize what's going on. Okay, there's your ball. It's going up into the air. And it's reaching its highest point and then coming back down. So you should know by now a couple things. You should know that the acceleration of gravity is constant. And at the highest point, when the ball's at the highest point, its velocity is 0. Okay, so I know gravity. Know the acceleration of gravity is -9.8. I know the initial velocity is what I'm trying to solve for. I know the velocity at the top, the highest point, is 0. And I know the height that the ball travels is 38.4 meters. Okay? So A, VI, VF, and D. When I look at what I have and I find my equation, I know that it's A equals VF squared minus VI squared divided by 2 times D. So now I can start plugging in everything I know. I know A is a negative 9.8. VF is 0 squared minus VI, which I don't know, squared, divided by 2 times D, which is 38.4. Okay. So I'm going to go ahead and simplify this a little bit, take it one step further. I'm going to rewrite negative 9.8. I know that 0 squared is 0, so this part essentially goes away, and all I'm left with is a negative VI squared. And then 38.4 times 2 is 76.8. Okay, so I've got VI as a numerator on the right. It's part of a fraction. I'm going to make the left side a fraction and cross multiply. And when I do that, when I multiply a negative 9.8 times 76.8, I get 752.64. And then when I multiply 1 times a negative VI squared, I get a negative VI squared. Okay, next step is to get rid of the negative that is on the VI. And so I'm just going to divide both sides by negative 1 to clear that up. Negatives go away. And I've got a positive 752.64 equals a positive VI squared. And my last and final step is to take the square root of VI squared to get rid of that exponent. And I get VI all by itself. And the square root of negative 752.64 is 27.43 meters per second. So its initial velocity on the way up is 27.43. Now, with that being said, if the velocity going up is a positive 27.43, then the velocity at the same point on the opposite side would be 27.43 down. It would be a negative 27.43. Okay, let's look at 20. It says a rock is knocked off a bridge by a passing car. The rock starts with an initial speed of negative 2 meters per second downward. How far will the rock fall before it reaches a negative 75 meters per second? Okay, so what does it tell me? Let's see. It says it starts with an initial speed of negative 2, so it tells me VI. It wants to know how far, so I'm trying to solve for distance. And it says how far will it fall if it reaches negative 75, so it's telling me that this is the final velocity. If it's falling, you know that its initial velocity, the initial velocity was given to us. But I know that gravity is pulling it down. So I know negative 9.8 meters per second squared. So I got VI, D, A, and VF. I'm going to use the same equation that I used up above, which is A equals VF squared minus VI squared divided by 2 times D. So I'm going to go ahead and plug in everything I know. I know A is a negative 9.8. I know VF is a negative 75 squared minus VI was a negative 2 squared, all divided by 2 times D. Okay. So next I'm just going to take that and simplify it just a little bit. When I take a negative 75 squared and subtract a negative 2 squared, I get a positive 5,621. I'm going to keep it written as over 2D equals a negative 9.8. And now I can cross multiply. So, fraction on the left, cross multiply. Negative 9.8 times 2d is negative 19.6. And 1 times 5,621 is 5,621. Oh, can't forget the d. There you go. And then get rid of the 19.6 to get d by itself. I've got to divide by negative 19.6 on both sides. These cancel. I've got d all by itself. And 5,621 divided by a negative 19.6 gives me a negative 286.79 meters. Okay, let's look down here at number 21. 21 says an airplane is landing at a velocity of 250 meters per second. The plane slows at a rate of negative 40 meters per second squared for 5 seconds. How far will the plane travel? Okay, so it says it's landing at a velocity of 250. So its initial velocity is 250 meters per second. It's slowing down at a rate of negative 40 meters per second squared. So what it's telling me is the acceleration is negative 40. It's slowing down. And it's slowing down for 5 seconds, so I know the time is 5 seconds. How far will it go? Well, that is d. So VI, A, T, and D. Equation I would use is D equals VIT plus 1/2 AT squared, where D is unknown, initial velocity is 250, time given to me was 5 plus 1/2, acceleration is negative 40, and time again is 5 squared. So 5 squared times a negative 40 times 1/2 plus 5 times 250. So I'll do this in a couple steps. 250 times 5 is 1250. And plus 5 squared times a negative 40 times 1/2 is negative 500. So 1,250 plus a negative 500 is 750 meters. Okay, on the right, last few. Number 22 says a car is traveling at 7 meters per second, speeds up at a rate of 4.1 meters per second squared for a period of 6 seconds. How fast will the car be going? Well, let's see here. It tells me that the car is traveling at 7 meters per second, so its initial velocity is 7. It speeds up at a rate of 4.1 meters per second squared, so that's my acceleration. It's doing that for a period of 6 seconds. So I know the time. And I want to know how fast it's traveling afterwards, so that is final velocity. Final velocity is unknown. Okay, so A, VF, VI, and T, my equation is A equals VF minus VI divided by t, where A is 4.1, VF is unknown, initial velocity is 0. No, excuse me. Initial velocity is not 0. Initial velocity is 7. And the time is 6 seconds. So VF minus 7 divided by 6. So I've got a fraction on the right. I'm going to make a fraction on the left. Cross multiply. So 4.1 times 6 is 24.6 equals, and then 1 times VF minus 7 is just VF minus 7. So to get rid of that 7, I do the opposite operation, which is to add 7 to both sides. 7's cancel over here, and 24.6 plus 7 gives me 31.6 meters per second as my final velocity. Okay, number 23. While driving his pickup truck, Joe stops at a red light. When the light turns green, Joe steps on the gas and accelerates to 20 meters per second in 5 seconds. What is Joe's acceleration? So I'm solving for A. Time is 5 seconds. He accelerates to 20 meters per second, so that's his final velocity. If he is stopped at the light, that means his initial velocity had to be 0 because he's stopped. Okay, so VI, VF, T, and A, I'm going to use the same equation that I used up above. A equals VF minus VI divided by T, where A is unknown, VF is 20, VI is 0, and time is 5 seconds. So 20 minus 0 is 20. 20 divided by 5 is 4. Okay, number 24. The car is approaching a stoplight. It slows down to a rate of -3 meters per second squared. That's acceleration. 4 seconds, that is time. To come to a stop, what's the car's initial velocity? So VI is unknown. If the car is coming to a stop, that means its final velocity is 0. So VI, VF, A, and T, it's going to be the same equation as above. VF minus VI divided by T, where acceleration is -3 because he's slowing down. Final velocity is 0 because he's stopping. Initial velocity is unknown, and time is 4 seconds. Okay, so 0 minus VI is simply just a negative VI. And now I can cross multiply. -3 times 4 and 1 times a negative VI. So -3 times 4 is a -12. And 1 times a negative VI is a negative VI. And to get rid of that negative, I simply divide both sides by a -1. The ones cancel. And a -12 divided by a -1 is a positive 12 meters per second as my initial velocity. Number 25. A wad of paper is thrown with a speed of 50 meters per second and slows at a rate of 5 meters per second squared. After 0.75 seconds, how fast will the paper be traveling? Okay, so it's thrown with an initial velocity of 50. It's slowing down at a rate of 5 meters per second. So this is acceleration, but the fact that it is slowing tells me that this is a negative 5 meters per second squared. And the time is 0.75. How fast is it going? Final velocity. Okay, so A, VI, VF, and T, same equation as above. Where A is negative 5, it's because it's slowing down. VF is unknown. The paper was initially traveling at 50 meters per second, and it's taking 0.75 seconds. Okay, so VF is part of a fraction. It's in the numerator. It's not minus 0, so I can't just delete anything, but I can set up a fraction on the left and cross multiply. So a negative 5 times 0.75 is a negative 3.75, and 1 times VF minus 50 is just VF minus 50. So to get rid of that 50 and have VF all by itself, all I simply need to do is add 50 to both sides. And when I do that, the 50s cancel out on the right, and I get VF all by itself. And negative 3.75 plus 50 gives me 46.25 meters per second as my final velocity.